What if I told you scientists just made an AI that works like the human brain, and it's 99% more energy efficient than today's neural networks? Yeah, this isn't sci-fi. It's real, and it might change how every AI model is built. AI is getting smarter every day, but also hungrier. Training one large model like GPT-4 can consume as much energy as hundreds of households do in a year. But now, researchers at the University of Surrey's NICE group have cracked something incredible. A new way to wire AI models that mimics how your brain connects neurons, cutting the energy use by 99% without losing accuracy. It's called Topographical Sparse Mapping, or TSM, and it could be the biggest step toward brain-like efficient AI we've ever seen. So here's the problem with today's AI. When you train a neural network, every neuron connects to every other neuron in the next layer, like trying to have everyone in a city call everyone else at the same time. It works, but it's ridiculously inefficient. Now, your brain doesn't do that. Instead, it connects neurons that are close together or functionally related, forming local neighborhoods of computation. That's what TSM does too. TSM reimagines AI architecture by limiting each neuron's connections only to nearby or related nodes, kind of like forming communities inside the model instead of a chaotic network. The result? Up to 99% fewer connections. But the crazy part? It doesn't lose accuracy. It even learns faster. In experiments, TSM models reach the same or better accuracy compared to traditional, dense models while consuming less than 1% of the usual energy. That's like going from a power-hungry data center to a solar-powered calculator without losing brain power. AI's energy problem isn't small. A single training run for a large model can produce as much CO2 as 5 cars over their entire lifetimes. And as models get bigger, this problem explodes. If we keep scaling like this, I could soon demand as much energy as entire countries. That's why this new idea is such a big deal. It's not just an optimization, it's a survival plan for AI's future. The human brain runs on just about 20 watts of power, less than a light bulb, and yet it outperforms the biggest supercomputers in flexibility and creativity. So the researchers at Surrey asked, what if AI learned from biology, not brute force? They took inspiration from how the brain grows and prunes its connections over time, strengthening useful pathways and trimming weak ones. That's where enhanced TSM or ETSM comes in. ETSM mimics that pruning process. As the AI trains, it figures out which connections actually matter and cuts the rest. Over time, it builds an internal map that's lean, efficient, and self-organized, just like the brain. And here's the kicker. It doesn't need special hardware. It works on existing GPUs and AI frameworks, meaning this could scale fast. In testing, ETSM models achieved up to 99% sparsity, meaning 99% of connections were gone, and still matched or beat traditional AI models in accuracy. Training time dropped dramatically, energy use fell off a cliff, and compute costs shrank. Think about that 1% of the energy, same accuracy, faster training. That's not just an improvement, that's a revolution. It's the kind of breakthrough that could make AI truly sustainable, and maybe even bring neuromorphic computing closer to reality. This brain-inspired approach could rewrite the rulebook for AI. Instead of building bigger and hungrier models, we might finally start building smarter and leaner ones, systems that think more like us. As we head toward an AI-powered future, breakthroughs like this might be what keep innovation alive without burning out the planet. Subscribe for more such videos and click on bell icon to get updated.